All right, last class we talked about information processing theory, and we tied in all the major subjects we've covered up until this point and connected those to information processing theory. So we talked about social learning, multiple intelligence theory, types of knowledge, and Bloom's taxonomy, and experiential learning theory as ways of paying attention to new and novel information coming in. Then we talked about the theory itself. So this is the dual store model. It's a model of information processing. So you have environmental stimulus coming in, and it goes into the sensory register. As long as you pay attention using one of those four: group learning, learning styles, types of knowledge, experiential learning, they help you be efficient at getting it over here to short-term memory so you can rehearse it and get it to long-term memory. We talked about how there was a limit to short-term memory and that there is also a capacity for the average person. Unless you have a photographic memory, then there may be no capacity because it goes straight from short-term memory to long-term memory. But for the average person, we have to rehearse things to get them into long-term memory. And now that takes us into the subject matter for today. I know this looks convoluted, but I just want to, since this is at midterm, I want to make some connections throughout the semester that we haven't made so far. And then we'll spend more time, instead of talking about just explicit memory and implicit memory, we covered those in depth at Types of Knowledge. I want to spend more time on the anatomy of learning and where is this happening in the brain. But first, let's look at this model. Let me just explain it. So we've got environmental information coming in. We pay attention to it through those four major subjects we covered in the first 4 weeks: social learning, learning styles, types of knowledge, experiential learning. That helps us get it over into short-term memory. It has a limited capacity, and we have to rehearse it to get it over here into long-term memory. If we don't, it'll be lost. It'll be forgotten. And we have about 20 seconds. We know this because damage to that region of the brain, people can't take information from the hippocampus, or if the hippocampus is damaged, they have trouble taking information from short-term memory to long-term memory. And that's really historically how we've determined what part of the brain does what is damage to that area. Somebody suffers trauma or disease, and we make observations about what's going on, what's changing. Okay, so we rehearse it, we get it over here in the long-term memory. When we talked about types of knowledge, we talked about explicit versus implicit. So we've covered this in depth. I don't want to spend too much time on it, but this is the cognitive domain of Bloom's taxonomy. And you've got explicit knowledge, declarative, episodic, semantic, and then semantic can be broken up into conceptual and conditional. And then on the implicit side, we've spent most of our time talking about the psychomotor, the activities that we're doing in class, the procedural knowledge that was important. But now in the second half of the semester, when we come back from midterm, after we finish our midterm project and manuscript, we're going to talk about behavior and motivation's effect on behavior, attribution theory, Yerkes-Dodson law, all of those things that are connect us to motivation and its impact on learning and behavior. All right, but before we do that, let's look at long-term memory, and let's look at these types of memories or types of knowledge, and where do they happen in the brain, and how is this connected to previous topics we've already talked about? So we've got the frontal lobe, and you've probably all heard of Phineas Gage. We found out what parts of the frontal lobe do back when, I think it was in the 1800s. Phineas Gage had a metal rod. He was putting a blasting cap in a hole. The blasting cap went off and shot the metal rod through his head, through his frontal lobe. Before that, Phineas Gage, super nice person. After that, he was a terrible person. So people made observations and said, okay, if you have damage to this area of your brain, it's going to affect your behavior. We still see that in modern times, right? That hasn't changed for us. We're still making the same observations, especially with football players. They tend to have concussions, and that damage tends to happen in the frontal lobe, and you start to see changes in their behavior. Aaron Hernandez played for the Patriots. Super nice guy before, turned into a terrible person after suffering a lot of damage to his frontal lobe. The prefrontal cortex is also involved in reading and writing. So those people that have that preferred learning style probably have well-developed regions of the frontal lobe. But the prefrontal cortex is the part that's involved in organizing behavior. So not only do we have a connection to the second half of the semester, but we have a connection here to the first half, especially in week 3 when we talked about multiple intelligence theory and learning styles. All right, let's go to the cerebral cortex. So these are the folds in the outer surface of the brain. That's where types of knowledge, types of memory, or long-term memory specifically, are stored here. So that's all over the brain in different areas of the brain. And in the parietal lobe, this is a different lobe, you have kinesthetic movement. So for me, I think I have a well-developed parietal lobe because kinesthetic movement, I can learn skills fairly quickly. Now notice the proximity of the parietal lobe to the occipital lobe, visual information, visual spatial, depth perception. These two go hand in hand. I think I have a well-developed occipital lobe because I do pretty good with visual information, visualizing information, and movement through space, and that goes hand in hand. So most of your kinesthetic learners, that's why they tend to be visual learners, because these two lobes of the brain are processing that information for them. Let's go to the temporal lobe because we talked about short-term memory to long-term memory. That's how we found out what the hippocampus does. So the hippocampus processing short-term memory. I give the example in class typically of this older guy. He had damage to the hippocampus. He can remember everything that's in long-term memory. So all the people he knew before, he can still remember all the events, and before the damage, he can remember. But anybody that's new that comes into his life, he won't remember them. Or the example I give in class is his wife could walk in the room and say hi, and he's like, hey, good to see you today. But he knows who she is. But if she walks out, waits for about 20 or 30 seconds, comes back in, he will have forgotten that he's seen her that day, and it's like he's meeting her for the first time. So that's how we determined what happens, or what does the hippocampus do? And when we found out that it processed short-term to long-term memory. He still has his short-term memory, but he doesn't have the ability to take those new memories to long-term memory, to the cerebral cortex. All right, then we have the amygdala. So people that have an irrational fear response or don't have a fear response or show signs of aggression may have damage to the amygdala. And then we have the basal ganglia, so emotion, reward. So when we get to reinforcement and we start talking about reward processing, that's going on there. So these are all in the same region. So the hippocampus and the amygdala are on this little structure, and I wish I had a visual of it, but it's kind of U-shaped, and they're on the same structure within the brain underneath this temporal lobe region. So auditory information, if you're a good listener, I had a buddy that was run over, had damage not only to short-term memory, but he lost his sense of taste and smell because his brain was swollen after he got run over, and he had damage to the temporal region. That's how they knew where the damage was, because taste and smell, and he had problems listening to people. And so your explicit knowledge from short-term memory to long-term memory is all happening here in the temporal region. And then fine motor skills. So this is procedural. It is kinesthetic, but we're talking not gross motor skills, the big muscle movements. We're talking about fine detailed skills like drawing. It's all happening here in the cerebellum. So I wanted you to know, where are these events taking place? How do we know that that's what that area of the brain does? Now we don't necessarily have to look for damage. We can do brain scans. Where is the brain active at when this process is going on? And so we're finding out more and more about the brain based on new technology that's coming out, allowing us to look at those brain waves, the brain activity, the electrical activity within the brain. It's all really interesting research. But I wanted you to know all these theoretical concepts, when we're talking about them, where are these happening at, so that you can kind of visualize where this is going on in the brain. Now, for this activity today, I want you to talk about the types of memory that are most important. I know we've kind of already covered this, and you can tell me what area of the brain you think is involved. And so that's where the new component of the theoretical information comes in. So we're going to be doing a pump drill. It has concepts that we already know, so this is going to deal with long-term memory, so there's going to be some explicit knowledge involved, but it's also going to involve implicit knowledge, procedural knowledge, and there's some fine motor skills that goes along with putting this together. So we're going to have involvement of cerebellum. There's going to be, for those visual learners, they're going to need to see this. That's going to happen in the occipital lobe. There is going to be a huge component when it comes to kinesthetic, so you want to put your kinesthetic learners on that, and that's going to be going down in the parietal lobe. You're going to have to rely on some long-term memory, some concepts you already know about spindles and counterweights that we had in the previous activity and ones before that. And there won't be too much reading and writing going on here. But there will be some auditory listening, and there's definitely going to be some short-term memories going to long-term memories because you're going to get a lot of repetition because this is a difficult activity. That's what I want you to talk about. What anatomical structures of the brain do you think are involved, and which ones are more involved than others? For me, if I were in your group, I would definitely talk about the importance of the parietal lobe in kinesthetic learning, occipital lobe in visual learning, but you may have some people in your group that would prefer to read and write about this, and if that's the case, that's what you would talk about. And this is going to lead us in to the second half of the semester, because now we're breaking up implicit knowledge into the affective domain of Bloom's taxonomy. So we're going to get into the behavioral side of learning and how motivation and reinforcement influence behavior.